The year is 3025. Due to human greed and its natural consequences, such as climate change, the population has drastically declined. Money doesn't carry the same weight it once did, and with there being fewer people around, especially in the rural areas, trading favors or goods has become far more common. You have retreated to a family farm, near the outskirts of civilization. You inherited this farm from your kooky uncle, shortly after graduating from one of the last high schools in your country. Technology is decently advanced, with most of the farm being automated. You only need to do regular maintenance to live comfortably in abundance with your dog Kevin. For better or worse, he's just about all that you have left in this world. You spend every morning with Kevin on the porch, drinking coffee and looking out at the farm. Kevin likes to run around, play fetch with you, or sometimes just wander off. He usually knows what he's doing, so you're not too worried about it when he does that. One morning, while you're looking out at the farm with Kevin, his ears perk up and he runs off. This happened to be on an inspection day. Once every week or so, you have to drive out to check on all the technology that keeps the farm running. While on these rounds, you notice that one of the towers on the farm is giving an alert. Unsure of what it's about, you make a note of it so that you can fix it later. You also notice several of the robots on the farm acting a bit strangely, but you don't think much of it since their control tower was just giving you an alert. After checking on the rest of the systems on the farm, and noticing a few oddities here and there, you realize that it's time to go back home. Upon your arrival, you see that it is almost time to feed Kevin. Strangely, Kevin isn't in the kitchen, like he usually is at dinner time. Alarm bells start going off in your mind, and instinctively you go to check your workstation, which normally allows you to keep track of various things on the farm, including Kevin.
Alert! Tower C is not operational. Tracking error.
This is bad. Your mind starts racing. What if Kevin ate a poisonous snake? What if he was eaten by a venomous snake? What if he was eaten by a non-venomous snake? What if he broke his leg, or more than one of his legs? What if he dug himself into a hole again? Or maybe someone took him? But wait, who would take Kevin? A dog napper? Perry the dog napper? You realize that panicking isn't helping. After a deep breath, you take a second to collect yourself and think. What do we know, and how can we use it to start looking for Kevin? This brings you back to the tracking system at your workstation. Now, here's how the tracking system would work on a normal day, supposing that Tower C is fine. The farm is represented by a grid, and the house is represented by the green dot, H. There are towers on the farm at known locations. These are, of course, towers A, B, and C. Kevin is represented by a red dot, whose location you can usually just read off of the screen easily. In order to display this dot to you, each tower, for example Tower A over here, sends out a pulse. Kevin wears a collar that reflects these pulses, which allows the tower to record how long it takes before it receives an echo of its own original pulse. We assume, of course, that each tower has its own frequency or its own recognizably distinct pulse, so that the towers don't interfere with one another. The time taken for the tower to detect an echo is then sent to the computer at your workstation, which knows what kind of waves we are working with, so it can calculate an approximate distance that the echo had to originate from. This idea is then used for towers B and C as well, allowing the computer to estimate distances from towers A, B, and C. These distances can be used to estimate Kevin's location. Specifically, you can use the distance as a radius from the tower and then find the location of a dot that simultaneously lives on each circle with the specified radii. When all three towers are working, there is a unique point of intersection. Using some basic knowledge about how the computer communicates with the towers, you're able to access the log files of the most recent pulses. It seems like Tower C went offline a few days after the previous inspection day. Because of this, the computer can no longer estimate Kevin's location. You realize that Kevin's approximate times from towers A and B have remained basically the same for a while now, which is very concerning. You're able to convert these times into distances by hand, finding that Kevin had to be the displayed number of units from Tower A and the other displayed number of units from Tower B. You realize that this is everything you need to know in order to be able to go looking for Kevin. Now, if you do not feel like you would be able to figure out where Kevin is based on only this information, then Brilliant might be able to help you out. Brilliant is where you learn by doing, with thousands of interactive lessons in math, data analysis, programming, and AI. As someone working in the mathematics education sector, my favorite thing about Brilliant is the way you can challenge your intuitions in their lessons. Specifically, there are problems built into the lessons, which you actually have to solve directly in order to proceed, meaning that you gain experience with problems that are usually realistic and relevant in a topic, rather than memorizing a bunch of theory. This enables you to become a better problem solver and a better critical thinker in general. It is often said that mathematics is not a spectator sport. You have to learn by doing, which is exactly what Brilliant has centered their approach around. However, instead of the experience feeling as if you're doing several homework problems, they've managed to gamify the learning. Thus, you start from the basics, and then the difficulty increases in a natural way, allowing you to master the fundamentals before you move on to the more complicated topics. I genuinely recommend going to brilliant.org/idkmath to try out the premium version of Brilliant for free for 30 days. You'll also be able to get a discount of 20% on the annual premium subscription. If you use Brilliant to do courses that you plan on taking in the future, or are currently taking, I believe that you will be a stronger student because of it. Thank you to Brilliant for sponsoring this video. Now, after finding the possible intersections of the last known distances from towers A and B, you notice that Kevin has to be in one of two areas, since he hasn't moved. Thus, you get in your farm buggy and drive out to go check. Your heart stops for a moment, and it suddenly feels like the air was stolen from your lungs when you arrive at the first location. There are clumps of fur on the ground and scratch marks in the mud that make it look like Kevin was dragged away from here against his will. Amidst the mess, you find his collar with a note next to it. You look at it with blurry vision, only to see a jumbled mess of letters as you begin to cry. You turn over the note to find a letter.
Hey kid, I didn't want some mouth-breathing brat taking over my farm and letting everything go to crap. I worked hard to make this place what it is. You want your dog back? Good. Earn him. The keyword is salt and vinegar. Good luck.
Your blood boils. You knew that your uncle was a bit eccentric, but this is too far. Did he fake his own death just to mess with you? It just doesn't add up. You have his ashes. He would have had to stay off of the grid for a long time. And Kevin meant more to your uncle than anything, so Kevin's almost certainly safe. Besides, your uncle wouldn't leave Kevin alone here for so long if he was still alive. He wouldn't be able to stay away from Kevin like that. Something else must be going on. You wonder about it for a moment, but to no avail. It doesn't make any sense. Eventually, though, it dawns on you. Maybe your uncle's right. Maybe you have been getting too comfortable on the farm. And perhaps this challenge is exactly what you need to get an innovative spark going. You pause for a second to take in the scene. Maybe you can find something that'll help solve this riddle. In fact, looking at the letter again, you originally thought your uncle is just bad at spelling, but that doesn't make any sense. He wouldn't have been able to make the farm what it is if he had been bad at spelling. You decide that it might be worth looking into the keyword more, since the bad spelling could just be a poor attempt at disguising the significance of vinegar or whatever. The drive home is eerie. You feel like you're leaving the venue after failing an exam. Still, it isn't too late for you to pass the course if you find out how to decrypt that stupid letter. You are vindicated as you look into salt and vinegar shortly after arriving back home. Specifically vinegar, actually. This is a type of cipher that can be used to encrypt a text message. To see how it works, consider the following example. You need a plain text message that you want to encrypt, and you need to use a keyword in order to encrypt it. For example, the plain text message could be something like test message hello hi, and the keyword can just be the word encrypt. You then need to consider how many letters are in the plain text message that you want to encrypt. In this example, there are 18 letters. Next, you write down the keyword repeatedly until you have the same number of letters as appear in your plain text message. For convenience, you can even space them the same way. Thereafter, you encode these letters into numbers. A is usually taken to be 0 and Z is usually taken to be 25. We now have two strings of numbers that we can add together. Once added, we may end up with numbers that are bigger than 25. We simply subtract 26 from those numbers so that they simply roll around into like a next alphabet, basically. This allows us to decode these letters so that they are gibberish to anyone who doesn't have the keyword. Now, suppose that you have an encrypted string that you want to decrypt. The process is quite similar. You count how many characters are in your encrypted string, before writing down the keyword back to back until you have that same number of characters. You can then encode these strings into numbers again, as before, with A being 0 and Z being 25. And then we take the difference between these numbers. Now, we may end up with numbers that are less than 0. In those cases, we simply add 26. This allows us to obtain a valid encoding of some text message, which is actually going to be the original plain text string. Thus, we can simply decode it, and then we obtain our plain text string from before. Punctuation is usually not encoded. With this knowledge, you're now fully equipped to decrypt your uncle's letter, which is exactly what you do. Once you have successfully decrypted the message, you notice that the letter says that Kevin is in a storage house to the northeast of Tower C. Without hesitating, you grab your keys and head out. After driving faster than you probably should have, you arrive at the storage house. The storage house is a bizarre sight. By now, it's dark out, and there's a big bonfire surrounded by dancing robots. You hop out of the bucky and sprint towards the commotion. You immediately look for Kevin, fearing that the robots could have fed him to the flames or something. But thankfully, that doesn't seem to be the case, as Kevin is sitting happily next to the bonfire, having a good time. You notice a banner saying, "Congratulations, took you long enough." A gesture from your uncle, no doubt. It seems that he left a few surprises programmed into the robots to help you remember his legacy. Thankfully, Kevin is in one piece, which is really all that matters at the end of the day. Just to be safe, you decide that you're going to keep an eye on him and take him to the vet in the morning. You sigh in relief, knowing that you've earned your place on the farm in some sense, with a renewed perspective and a desire to innovate and improve, rather than just wasting your days. Thank you for watching. I hope you enjoyed.